All right, what is the domain of each of these answers? Okay, so let's look right here. Someone impressed the heck out of me. What are our domain rules? We need to know these. We had a little quiz over a while back. What are the domain rules?
The radical or square can't be on numbers.
Okay, that's exactly right. If you don't have a radical or a fraction, chances are the domain is going to be all real numbers, unless it's a weird function like the logarithm function or something like that. But if it's a straight polynomial, if you don't have a fraction and you don't have a radical, then your domain is all real numbers. So the domain for number 1 is all real numbers. What about number, or B, I guess these are lettered. What about B? All real numbers. What about C? What about D? Now wait, now we got a problem. This one is not all real numbers because why? It's a fraction. What is our rule, our domain rule for fractions? The denominator can't equal 0. So x squared cannot equal 0, which means what about x? X can't equal 0? That's your domain. So your domain for letter E is x can't equal 0, which means x can be anything except 0, because that problem had a fraction in it. Now, starting with G, we have a whole different situation. Does anybody know how to deal with this? You've done it before. What do you remember about that?
Don't you plug the 2 into the G equation and plug that answer in?
That's exactly what you do. She said, don't you plug the 2 into the G function. In other words, don't you find G of 2? Yes. And if we plug, our G function is x squared. So if we plug 2 into it, it would be 2 squared or 4. Then, so this right here, this is G of 2. So this is 4. So now the problem says f of 4. So f of 4, our f function is x plus 2. So f of 4 would be 6. And that's the answer to the problem. Well, you remember doing that from last year?
Something like that.
This is called composition of functions. Does anybody know how to read this? Like if you were talking to like one of these absent people on the phone, how would you read that? F of G of 2. F of G of 2. And just like you just did, we kind of go backwards. So we start with the G function and then go to the F function. All right. Now, here is something interesting. So this is problem G. Problem H, believe it or not, guys, is exactly the same thing, just written with different notation. That is a little open circle, kind of like a degree mark, like if you wrote 32 degrees, only it's down here. It's not written above, it's written right here, but it's just a little open circle, and this means exactly the same thing. It's just a different way of writing it. This means f of G of 2. So you have 2 different notations for exactly the same problem. So the answer to this one, the answer to this one is also 6. It's exactly the same problem, just written differently. When we do composition, we work backwards. So we plug the 2 into the G, and then we plug that answer into the F. Now, is I a different problem, or is it the same problem all over again? Different. What's different about it? It's the other order, yeah. So we're doing g of f of 2. So that means we start by finding f of 2, which is 4. This is 4. So now we're going to find g of 4. And g of 4 would be 16. So the answer to the problem is 16. The order that we do f and g matters. Because when we did g first and then f, we got 6. But when we did f first and then g, we got 16. So you got to pay attention. And remember, you go this way. It's one of the few times that we go right to left. All right, on your own, find h of f of negative 1. That's how we say that. H of f of negative 1. So go ahead and figure that out. The h function, bless you, is negative 2x plus 5. So go ahead and see if you can figure out what h of f of negative 1 is.
You said with the ones that have the little degree sign in the middle, you always work from the
You go the same direction.
Okay.
So it's backwards, yep. Right to left. Okay, so Miss Piper, I'm assuming, since you're talking about that problem, that you've already done this one? What did you get for this one?
3.
She got 3. Anybody want to agree or disagree with that? 3 is right. Because f of negative 1 is 1, and h of 1 is 3. Perfect. Beautifully done. Now she's working on the next one, which involves 3 functions. Doesn't matter. You can have as many as you want. The idea is the same. You just start right here, and you just keep going. So what's h of 1? 3. Okay, so h of 1, we did h. So now we're ready for g. What's g of 3? 9. Now we're ready for f. What's f of 9? There's your answer. Everybody okay with that? All right, let's see what's next. Oh my, what does this mean? Any thought on this? What in the world do I do with that? So, where do I start? With the g, right? So it says g of x. I start with g of x. This is g of x, which is x squared. So this right here is x squared. So it says find f of x squared. Isn't that what it says? Find f of x squared, which means go back to your f function, and every time you see an x, put in an x squared. So the answer is going to be x squared plus 2. That's exactly right. That's exactly right. How about h of f of x on the next page? H of f of x. So what do we start with? F. And the f function is x plus 2. So this here, right here, this right here is x plus 2. Where my hand is x plus 2. So we're finding h of x plus 2. So we go to our h function, and every time we see an x, we have to put in x plus 2. So we have negative 2 x plus 2 plus 5. Johnny?
Yeah.
Sit up. Was football breakfast good today?
That's all right.
No? What do you kind of had the same look my husband has on Thanksgiving after we've eaten the meal, and he goes in the, I couldn't hear that, but okay. Alright, so our answer is negative 2x minus 4 plus 5, which is negative 2x plus 1. So when I just distribute and collect like terms, this is what I get for my final answer. Everybody good with that? We have one more topic to talk about, implicit functions, but before we do that, somewhere, I think you should have a little bit of room. I want you to do 2 quick review problems for me. I just want to make sure we've got this under control. So I want you to sketch that, and I want you to use these functions and find g of f of x. All right, so we're just going to quickly, we're going to do these 2 problems to kind of recap. This is from just now, and this is from yesterday. I want to make sure we remember that. So right now, just on your own, just hang on for a minute. On your own, see how far you can get with these 2 problems. Use these same functions for this problem right here. See how far you can get with those 2 before we talk about our implicit functions. Olivia, what was your comment?
I was gonna ask if you use those to fill in.
Yeah. Yeah. What shape do we have here? That's going to be a V. And normally it would be V'ing from here, right? That would be the normal absolute value. What's happened to this one? Right 3 and up 1. That's exactly right. Very good. So this V is V'ing from the point 3, 1. Remember, when you attach the number inside the function, like inside the absolute value or inside the squaring or inside the exponent, whatever it happens to be, when you put it inside, it moves you sideways. X minus 3 goes right, x plus 3 goes left. When the number is just tacked on outside the absolute value, outside the square, outside the exponent, when it's just tacked on, then you go up and down. Plus 1 goes up, minus 1 would go down. We have to know those rules. All right, what about this one? F of x is x plus 2. This right here is x plus 2. So we're going to take x plus 2 and plug it into the g function. So g of x plus 2 would just be x plus 2 squared. Or if you foiled it, and it is a FOIL, please FOIL if you're going to multiply it out. It's a FOIL. There we go. You okay with that? So we have one more thing. That's talk about implicit functions. I want you to think about, well, first of all, you may know what shape that is. You should know. It was in our last chapter, chapter P. What shape is that? That's a circle. That's a circle. When you got x squared and y squared added together, you have a circle. Is a circle a function? No. Here's the situation, folks. You can't graph that on your calculator. Because in order to graph on your calculator, when you go to put an equation into your calculator, what button do you press in order to put the equation in? Y equals? Is there a button that says y squared equals? No, it's gotta be y equals. So in order to graph this on my calculator, I have to turn it into a function. A circle is not a function. So what I'm going to do is I'm going to take this circle and I'm going to get the y by itself. So I'm going to subtract x squared, right? And then guess what I'm going to do? But when I square root, I have to remember to do the plus or minus. So I'm going to take the square root of both sides here. So y is either going to be the positive square root of 4 minus x squared, or y is going to be the negative square root of 4 minus x squared. And I want you to write them separately, because now we're going to put them in our calculators. Did you bring the calculator today? Then get it out. God bless you. Remember, you're supposed to have a graphing calculator with you every single day. So get it out. If you don't have one, lean over to your neighbor so you can see what's going on. Clear out any old equation that you still have in there. Does everybody know where your square root key is? And remember, for the second equation, when you put in the negative, make sure you're using the negative button in the bottom. Don't use the minus button. Don't use the subtraction.
It's supposed to be all
Radical 4 minus x squared.
What?
It's supposed to be filled in on colorful? I know that's not.
Supposed to be filled in? No, not really. But I mean, you have something set so it's filled in. All I really care about you seeing is that when you graphed the top equation, you got this. And when you graph the bottom equation, you got this. So putting the two equations together gave you the circle. Now, if you look at just the top half, is that a function? Is the top half a function? If we look at just the bottom half, is it a function? Yes. That's why the two halves are called the implicit functions. They are the two little functions that make your graph. So when somebody says to you, find the implicit functions, they mean solve for y. And it's always, almost always, going to involve a plus or minus situation. Okay? Everybody getting that circle? All right, so try the next one on your own, letter B. Try letter B on your own. It, by the way, is not a circle. Letter B is not a circle. So we're finding the implicit functions, and then we're going to graph it and see what kind of shape we get. Anybody know how I know that's not a circle? What's my clue that's not a circle? X isn't squared. Anybody know what that is? It's a parabola. But it's a parabola with a y squared, so it opens this way. It is not, actually, I think that one's going to open to the left. And open like this. But it's not a function. But when you get it down to the two implicits, one of them is going to graph the top half, and one of them is going to graph the bottom half. And those are the implicit functions, each half. So first we need to solve for y. So are you doing that? Andy, what are you doing? Did it have anything to do with implicit functions?
Yeah.
It did?
Yeah.
Well, then go ahead and tell the story. So my implicit functions are 8 minus 2x and negative the square root of 8 minus 2x. Those are my implicit functions. Everybody okay with getting the equations? I I gotta move my 2x over and then take the square root. Now, when you graph these, hopefully, one's gonna be the top half and one's gonna be the bottom half of a parabola. And then I want you to tell me why that makes sense. Square root 8 minus 2x. Negative square root 8 minus 2x. Oh, did yours look funky?
Yeah. What? Just to the left of the x-axis.
Alright, wait, I gotta figure out how I can make that look better. There we go, now mine looks okay. Now it looks okay. So I got this shape exactly. Looks kind of like that. Did you get that? Now, when you graph, guys, listen. When you graphed this, just that first one, you got this shape. Does that look at all familiar to you? It's a square root function. Oh no, does it make sense that it would look like a square root function? What's different about it though? It's going the wrong way. Does anybody have any idea what made that happen? The negative. When the x is made negative, when that x is made negative, it turns things backwards. So that's why it's pointing that direction. If we would have had 2x minus 8, then it would have been going the same direction as it always goes. It would have been moved, but it would have been going the same direction. Okay? All right, let's see what time it is. All right, let's finish this up. Let's see if you can get your other implicit functions written. So on your own, can you do C and D? Remember, your objective is to solve for y. So get y by itself. Your very last step should be square rooting. Ava!
I said Precal stop when I actually said that.
So remember, Mrs. Ford actually wants you to write 2 separate equations because that's what you're going to be typing into your calculator if you were going to graph it. Does anyone have a question about these equations? This is C. Everybody okay with that?
Is there a reason you don't put the negative x first?
No, you could. Yeah, you could. Doesn't make any difference.
Just preference.
This one's a little harder.
Wait, my things don't touch.
They don't? That might happen. Let's talk about that in a minute. Let me get this other equation written up here. And let's talk about the shape that you got. I'm glad you graphed it. All right, so here are my 2 implicits for that last one. That was a little harder, but remember, here was the original equation. Remember, you're trying to get y by itself. So there's no one way to do that, but we've got to get the y by itself. So first thing I did was move these 2 so that I had the 4y squared. Then I divided by 4, and then I took the square root.
You do x over 4 minus 4.
No, no. You cannot take the square root because of the minus. Now, you could if you wanted to, and I wouldn't suggest it because we're going to graph these on our calculator, but you could, if you wanted to, make this the square root of x minus 16 over 2. But I would just leave it like this to put it in my calculator. All right, so stop. Whoa, wait a minute. I want to graph one of these first. What did, are we okay with these equations, and are we okay with those equations? Because that's the test question. The test question says, what are the implicit functions? So it would be these two equations for that problem and these two for that problem. Nope, you're not going to have to draw them. Now, but for fun and just for our own like knowledge, did you graph this? I know somebody tried and they didn't quite connect, but what general shape did you get, even though they didn't connect? What? Actually, it's not a circle, it's an ellipse or an oval. This one is an ellipse or an oval. What happened on this one? You probably didn't get a chance to graph it. This is going to be another parabola because only one of the terms is squared, so it'll be another parabola. All right. Well, wonderful, wonderful people. On Monday, we will have a quiz, DFS, and then we will actually be ready to start reviewing because we've covered all the material. Magnus, can you turn that
Well, I think the second is on my phone.
Okay, I need to